Welcome to Kaspa R&D Weekly Pulse. 2 Kaspa nodes are online, ready to connect, and somehow, a pair of ordinary home routers keeps them apart.
The routers look harmless, but Luke's networking prototype now faces its biggest question. After repeated success on Kaspa's development network, will it connect nodes reliably through real home routers on Mainnet?
That is our route today. Why routers hide nodes, how automatic TCP hole punching tries to help, and why capable volunteers are now essential.
Start with the contradiction.
My Kaspa node can reach the internet. Why can't another node easily reach mine?
Because going out is different from letting someone in. A home router lets several devices share one public internet address, but incoming traffic does not automatically know which device should receive it.
So the node is connected, but hidden.
Exactly. That is a NATed node. A node behind a router sharing one public internet address among multiple devices.
Nothing is necessarily broken then.
No. The router is doing ordinary router work. Unfortunately, that ordinary behavior can make direct peer connections harder for a Kaspa node.
The usual response can involve port forwarding, right?
Yes. The operator manually tells the router where to send incoming peer-to-peer traffic. It can make the node reachable, but now running a home node includes changing router settings.
And those settings vary.
They do. The practical problem is simple, even if the menus are not. A person may want to run a Kaspa node without also becoming the household networking specialist.
So what is the prototype attempting?
Automatic TCP hole punching. It tries to connect 2 privately networked nodes without requiring either operator to set up port forwarding manually.
Jamie, translation request, less punching, more plain English.
Fair. Picture 2 people inside different buildings. Each front desk blocks unexpected visitors. They coordinate from inside so a connection can pass between them without either person rewriting the building's entry rules.
Useful picture, but routers are not front desks making decisions.
Right. The analogy only explains the practical shape of the problem. 2 hidden sides coordinate an outgoing action, and the method tries to turn that coordination into a direct connection.
So put the benefit first.
If this proves reliable on Kaspa Mainnet, a home node operator could eventually avoid manual peer-to-peer port forwarding.
That is concrete.
And limited. It would address this particular connection obstacle. The evidence does not say every router problem disappears or every peer connection becomes guaranteed.
Still, Luke has moved beyond a paper idea.
Yes. After repeated testing and adjustment, Luke reported working automatic connections between private or NATed nodes on Kaspa's devnet.
Devnet meaning the development network, where changes are tested before the live network.
Correct. And Mainnet is Kaspa's live network, where this implementation still needs testing.
Here is my pushback. If it worked repeatedly, why not say the router problem is solved?
Because those tests establish that the prototype can work under the development conditions tried. They do not establish reliable behavior across the variety of routers and network conditions found in ordinary homes.
Isn't that an extremely cautious standard?
It is the standard implied by the intended benefit. If the goal is easier connections from real home networks, evidence from real home networks is not an optional extra.
So repeated success answers, can the door open?
Mainnet testing asks, does it open dependably where Kaspa operators actually need it?
Better. Keep it there.
And we should state the boundary once. This is a promising public prototype, not a released Mainnet feature. Reliable operation behind ordinary home routers remains unresolved.
Which means I cannot open my Kaspa node settings today and switch it on.
No. Ordinary users cannot currently use it without building a special Kaspa branch from source.
That changes the invitation considerably.
It does. Luke is seeking Mainnet testers who can build that branch, run it behind a normal home router, and report detailed findings.
So, not casual clicking.
Not yet. This stage needs people comfortable with an experimental build and careful enough to explain what happened.
What would one successful home test prove?
That the implementation worked in that setting, which would be useful, but the supplied evidence does not define how many tests would establish reliability.
Then failures matter too?
They can. Detailed results help show where the behavior holds and where it does not. A failed connection would not automatically kill the idea, but it would be relevant to the reliability question.
That makes the volunteer request feel less like promotion and more like investigation.
That is what it is. The prototype has cleared a development hurdle. Now it needs varied, real-world observations before Kaspa can treat it as a dependable mainnet improvement.
Let me make that less technical. The developers got 2 hidden nodes talking in repeated rehearsals. Now they need to try the same thing in people's actual homes.
Yes, with one addition. Those homes are using Kaspa Mainnet, and testers must run the special branch rather than the ordinary software experience.
Why test on Mainnet at all? If devnet already models Kaspa connections, what changes?
The important change is the environment. Devnet demonstrated working behavior under development testing. Mainnet testing puts the prototype on Kaspa's live network behind ordinary routers, which is where its proposed value must hold.
And home networks are untidy.
At least varied. The evidence does not list every possible difference, so we should not invent them. What it does establish is that devnet success has not settled mainnet reliability.
Could testing on Mainnet be mistaken for available across Mainnet?
Very easily, and they are not the same. Testers building a public branch from source is fundamentally different from a finished feature reaching ordinary Kaspa node operators.
That distinction changes the mood. This is not launch day excitement.
No, but it is not merely theoretical either. Repeated devnet success shows that automatic coordination between hidden nodes is possible in the tested development setting.
So, caution without deflation.
Exactly. The prototype earned the next test. It did not earn a declaration of universal reliability.
What would success eventually feel like for the operator?
Potentially less setup. A Kaspa node behind a private home network could connect automatically without the operator manually configuring peer-to-peer port forwarding.
No new networking ritual.
That is the possibility, but eventually is doing important work because today's reality still involves source code, a special branch, and detailed testing.
Which part excites you more, the working devnet connections or the practical benefit?
The link between them. A clever networking result matters here because it could remove a specific burden from running a Kaspa node at home. Without that practical link, it would just be an interesting demonstration.
I'm slightly more interested in the unresolved part.
Why?
Because the question has become sharper. A week ago, someone might ask whether hidden Kaspa nodes can coordinate automatically at all. Now, repeated devnet tests let us ask the harder question. Can they do it dependably on the live network?
That is, progress measured by the quality of the next uncertainty.
Careful, that sounds abstract.
Let me restart. The first door opened in testing. Now, volunteers need to find out whether real home doors open too, and whether they keep opening reliably.
Much better.
Would you call the current tester requirement a weakness?
As a user experience, yes, because building from source is not simple access. As an experimental stage, no. The special branch is the thing being tested, and demanding testers can produce the detailed findings the work needs.
That is the right tension. It is not ready for casual use, but it may be ready for serious validation.
And serious validation can prevent a promising convenience from being announced before it is dependable,
while also giving the prototype a fair chance to show where it works. We do not know the outcome yet.
So answer the title question. Can Kaspa nodes escape the router?
On DevNet, Luke repeatedly connected private or NATed nodes after testing and adjustment. On Mainnet behind ordinary home routers, reliable automatic connection has not yet been established.
A qualified yes, followed by an open question.
More precisely,
evidence that the method can work, followed by a test of whether it works reliably enough in the setting that matters.
And if that test goes well, the payoff is refreshingly ordinary.
A person running a Kaspa node at home may eventually have one less router task to handle.
No promise that networking becomes effortless.
No, just the possibility of removing manual peer-to-peer port forwarding from this part of the connection process.
Back to our two nodes then. Both are online. Both sit behind blinking routers. For the first time in this story, the interesting obstacle is no longer whether they can coordinate at all.
It is whether that coordination holds up across real Kaspa mainnet connections in ordinary homes.
This week's result is therefore not a finished convenience. It is a working development prototype, asking capable volunteers for the evidence that comes next.
DevNet success opened a possible route through the router. Building the special branch and testing it on Mainnet will show how dependable that route really is.
That is the Kaspa takeaway. Automatic connections behind home routers look promising, but real Mainnet testing still stands between a successful experiment and an easier home node experience.